In this video, we're going to be taking a look at tangent and cotangent graphs. The easiest way to kind of understand what is going on with each one of these trig functions is to understand that anytime that you are looking at a tangent function, you are going to end up increasing from left to right. Now, also keep in mind, this is when the equations themselves are positive. When it is negative for tangent, it would actually decrease, but originally as positive trig functions, you're going to see that your tangent trig function increases from left to right and your cotangent decreases from left to right. So in slide 2, we have both the properties and an example of what a tangent function would look like. So we begin with the most important parts, which would be kind of understanding the domain range and the function of how it looks, as well as its period. So with a tangent trig function, you're going to notice that whenever we see the multiples of pi over 2, that will basically cause an asymptote to be at every single one of those odd multiples of pi over 2. Now this is going to go from negative infinity all the way to positive infinity at every odd multiple. So for example, on the slide or image on the right hand side, you see negative 5 pi over 2, negative 3 pi over 2, negative pi over 2, pi over 2, negative positive 3 pi over 2, and 5 pi over 2. At every single one of these intervals, you're going to notice that there's an asymptote at that spot, and that will continue to occur to negative infinity and positive infinity. The range, on the other hand, will go from negative infinity to positive infinity, so it's going to be all real numbers. You can see it here. It continues to increase upwards, and it continues to decrease downward. There is no breaking point at any given point. When we take a look at the trig function for tangent, it is also going to be seen as an odd function. So it is a symmetry that goes from the first quadrant to the third quadrant, and it is a reflection over the origin. Now, one difference that you will see is that here in a tangent function, the period is pi. Our x-intercepts are going to occur at every pi interval. So we're looking at negative 3 pi, 4 pi, negative 5 pi, negative 2 pi, negative pi, 0, pi 2, 3, 4, 5, 6, 7 pi, all the way up to infinity. You will end up being at an x-intercept at every single one of those pi locations. In this case, your y-intercept will be 0. And you're going to notice that every single one of your vertical asymptotes will occur at that odd multiple of pi, as we were stating before. So in slide 3, we start going over some of the different formulas that we were ultimately using before, and you will see some overlap from previous equations to now, but there are also some differences. One of the first differences that you will see is that in this equation, at the top of your screen, notice we have a plus k rather than plus d. This is one of the first differences that you're going to see between tangent, your cosine, and your sine. As we figure out our period, keep in mind, remember how we said our period is pi. So the first equation to solve for your period would be pi over b. So this would be a difference. Your interval is still going to be period over 4. In this case, this would remain the same as when we were working with our sine and our cosine. There is one new topic that we will have to completely learn separate from cosine and sine, and that is finding two consecutive vertical asymptotes. Every single time that we are working with this question, we are going to use these two equations. Now, that equation is mainly coming out of the bx minus c portion of your equation, and that is going to equal the positive and negative pi over 2. The reason why you're looking for the negative and the positive is because, remember, they are on opposite sides of your 0, which means that you will be able to find consecutive vertical asymptotes. As we stated before, the k in this equation still would be there, and in this case, it would represent your midline. Now remember, your midline can also be represented by d within sine or cosine, but within tangent, it's going to be represented as a k. Your a value is still your amplitude, and that remains the same. Let's go ahead and take a look at example 4. Now, in this problem, we first begin with tan of x minus pi over 4. The entire problem as a whole still repeats itself very similar to that of sine and cosine. We're still going to find our a value, which is still located in the same place. In this case, our a value is still 1. Our period is going to be pi over 1, which is equal to pi. Our subinterval will be pi over 4. And our midline in this case would be 0. Now, as we figure out our consecutive vertical asymptotes, we're going to go ahead and set the inside of that parentheses, which is x minus pi over 4 equal to negative pi over 2. And we're going to do the same thing for the positive version. Now, we already know that moving over the negative pi over 4 to the right-hand side would be the way to isolate your x. But before you can do that, you have to convert your negative pi over 2 into a denominator that works with pi over 4. In this case, we're going to go ahead and rewrite the equation with a denominator of 4. So x minus pi over 4 is equal to negative 2 pi over 4. X minus pi over 4 is equal to 2 pi over 4. We're going to go ahead, we're going to move over that minus pi over 4 to the right-hand side. So we're going to add that to both sides. We're going to end up with x is equal to negative pi over 4. And on the right side, we're going to end up with x is equal to 3 pi over 4. This would be considered your start when we are looking at the negative pi over 2. And this would be considered your end when we're working with the pi over 2. So in this case, your answers to the consecutive vertical asymptotes would be negative pi over 4 and 3 pi over 4. First thing we're going to do when graphing, we're going to go ahead and take a look at the midline. Our midline in this case is going to be 0. So we're going to go ahead and draw our dotted line going across the x-axis. Since we're going to start at negative pi over 4, we're going to go ahead and mark that off. Negative pi over 4, 0, pi over 4, 2 pi over 4, and 3 pi over 4. Now these locations of negative pi over 4 and 3 pi over 4, what that's actually going to do is going to tell us exactly where our asymptotes are going to be. In this case, we're going to have a vertical asymptote at negative pi over 4 and 3 pi over 4. We're going to go ahead and find the midpoint on our midline. So we're going to find the middle of our midline, which in this case would be a positive pi over 4. Our amplitude is going to tell us exactly how much up we will go from left to right from our midpoint. So as we move to our next point, 2 pi over 4, we are going to move over to the right one. The A value will tell us how high up we will go. So our next point would be right 1, up 1. And we're going to do the complete opposite to the left of the pi over 4. So we're going to go left 1 and down 1. We're able to do this because the equation as a whole is positive. We go ahead and draw our line's getting closer and closer to the asymptotes in an upward direction. This right here would be your graph of tan x minus pi over 4. Let's go ahead and take a look at slide 5. In slide 5, we can see that we're going to begin with tangent of x over 2. We go ahead and solve the beginning portion just as we would any other equation. A value would be 1. Your period would be pi over 1/2, which is also equal to 2 pi. Your subinterval is 2 pi over 4, which is equal to pi over 2. Our midline in this case will be 0, and we're going to go ahead and solve for our consecutive vertical asymptotes. In this case, x over 2 is equal to a negative pi over 2, and we're going to do x over 2 is equal to pi over 2. In this case, we know that x is equal to negative pi and x is equal to pi. Now keep in mind, we are still comparing our consecutive vertical asymptotes and our sub-intervals to make sure that they have the same denominators. In this case, we're going to want to go ahead and convert negative pi to have a denominator of 2, which would give us a negative 2 pi over 2 and a positive 2 pi over 2. We're going to go ahead, start with the midline, and draw our dotted line going across that x-axis. We'll find the midpoint at the very beginning between our two asymptotes after we have placed those on our graph. We know that they're going to begin at negative 2 pi over 2, negative pi over 2, 0, pi over 2, 2 pi over 2. Our vertical asymptotes are going to hit at the negative 2 pi pi over 2 and the positive 2 pi over 2. As we said before, we're going to find the midpoint on our midline, which in this case would be the 0. We were looking at a positive equation, which means from left to right, we are going to increase. So as we move towards pi over 2, we're going to move right 1. Now we take a look at the amplitude, and we're only going to take one step up. As we move to the left, so we're going to move left 1, we are going to move down 1. Once again, this is based off of our asymptote more than anything else. You go ahead, connect your dots, and you are all set for that equation. Let's take a look at slide 6. Now with slide 6, we made a slight little adjustment to the problem itself, and we added a plus 2 in the place of k. We did that to be able to kind of show what would come out of the problem if you were to have a k value in there. So the first thing that we do is we start off with our a value, which would be 1. Our period would be pi over 1, which would be the same as pi. Subinterval would be pi over 4. And our midline in this case would be 2. We're going to go ahead and find the consecutive vertical asymptotes. So x is equal to negative pi over 2, and x is equal to pi over 2. Once again, our subinterval and our consecutive vertical asymptotes should have the same denominator. In this case, 2 and 4. We're going to go ahead and rewrite this as x is equal to negative 2 pi over 4 and 2 pi over 4. We're going to start drawing everything out. First thing would be drawing our midline, going across from left to right. In this case, we're looking at a positive 2. From that positive 2, we're going to find our asymptotes, which are going to be at negative 2 pi over 4. And a positive 2 pi over 4. You do want to go ahead and label your x-axis. So this would be negative 2 pi over 4, negative pi over 4, 0 pi over 4, and 2 pi over 4. You're going to go ahead, find your midpoint. In this case, it would be at the 0. Now, remember, your 0 is going to fall on your midline at all times. From here, remember, our a value is 1, so as we go right 1, we are going to go up 1. And remember, this is the case because we have a positive equation. As we move left 1, we're going to move down 1. Once again, you connect your dots, move up and to the right, down and to the left. Let's take a look at slide 7. With slide 7, we're looking at a very similar problem to what we had accomplished before. Here we also added a k value. We're going to go ahead, start off with our a value, which is going to be 3. Our period is going to be pi over 2. Our subinterval would be pi over 2 and that's going to be divided by 4. When that happens, you're going to end up with pi over 8. Your midline in this case would be -1. And we're going to set 2x is equal to negative pi over 2 and 2x equal to pi over 2. We're going to go ahead, divide both sides by 2. In this case, x is equal to negative pi over 4, and x is equal to pi over 4. Keep in mind, we have a denominator of 8 for the subinterval, so we're going to have to make sure that they are equal to each other. So in this case, we're going to go with negative 2 pi over 8 and 2 pi over 8. As we start graphing our lines, we're going to first start off with our midpoint, our midline, dotted line going across the -1. We go ahead, set up our intervals of negative 2 pi over 8, negative pi over 8, 0, pi over 8, 2 pi over 8. We know that our two asymptotes are going to fall on -2 over 8 and positive 2 pi over 8. We find the midpoint on our midline, which would give us 0, -1. Keep in mind, this equation is positive, so we're going to go ahead, move right 1 and up 3. So 1, 2, and 3. As we move left, we're going to go left 1 and down 3. 1, 2, and 3. Once again, connect the dots. And that would be our graph for slide 11. In slide 8, we begin with our cotangent function. Now, there are many things that are very similar within the cotangent and tangent functions. If you take a look at the initial picture that we saw in slide 2 and compare it to slide 8, you can see that it is a reflection of what the tangent is. On the vertical side, when considering the two sides are asymptotes. So we go ahead, take a look at slide 9. Notice everything is the same in reference to our tangent. We're still looking at it being plus k. We're still looking at pi over b, our period over 4. Now, here's one of the largest differences that you will see. Our two equations that we were using for consecutive vertical asymptotes have kind of changed. It's going to be equaled to 0 and equaled to pi. Your a value is still the same. Your k value is still your midline. Let's go ahead and take a look at slide 10. So the first thing we're going to do here is graph the cotangent of x. We go ahead, take a look at the a value. In this case, a would be 1, pi would be pi over 1, or pi. Our subinterval would be pi over 4. Our midline would be 0. And the consecutive vertical asymptotes would be our equation of x is equal to 0 and x is equal to pi. We go ahead, check our subinterval. Notice we need a denominator of 4, which means this would give us 4 pi over 4. First thing, graph that midline. In this case, it's going to be at 0. Label out your x-axis. Notice we're starting off at 0. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. We know that our vertical asymptotes are going to occur at 0 and at 4. You're going to go ahead, find the midpoint on our midline, which is going to be 2 pi over 4. Now, since we are looking at a positive cotangent, rather than increasing from left to right, it's actually going to decrease. So we are going to move to the right 1, and the value is still 1. So we are going to go right 1, down 1. When we're going to the left, we're going to go left 1 and up 1. And that would be our cotangent graph. Let's go ahead and take a look at slide 11. In this case, we've got 3 cotangent x plus 2. Our value for a would be 3. Our period would be pi over 1, or pi. Subinterval would be pi over 4. Our midline would be 2. We're going to end up with x is equal to 0 and x is equal to pi. Now remember, we have pi and our subinterval is pi over 4, so we're going to go ahead and make this into 4 pi over 4. Our midline is going to be 2. We know that our starting point for our asymptote is going to be at 0. So that's going to be our y-axis. And we're going to be at 4 pi over 4 for our other vertical asymptote. We go ahead, label our x-axis, so 0, pi over 2, 2 pi over 2, correction, not 2, 4, 3 pi over 4, 4 pi over 4. We find our midpoint on our midline. Now keep in mind, we are looking at 3 cotangent of x plus 2. It's a positive equation, but even though it's a positive equation, we are still looking at cotangent, which is going to cause it to decrease from left to right. So as we move to the right, we're going to go right 1. Because our a value is 3, we're going to go ahead and drop down by 3. So right 1, down 3. As we move left 1, we're going to increase by 3. So 1, 2, and 3. this line would move that way. And go in that direction for that problem. Let's go ahead, take a look at slide 12. For slide 12, keep in mind we are working with a negative cotangent of 1/3 x minus pi plus 5. First thing to automatically spot is that because of this negative, we will have a flipped equation in reference to cotangent. We begin with our a value, which is going to be 1. Our period is going to be pi over 1/3, which is equal to 3 pi. Our subinterval is 3 pi over 4. Our midline is going to be 5. Now, for this inside part, what's going to happen is we're going to get the inside part of our parentheses, so 1/3 x minus pi, set that equal to 0, and 1/3 x minus pi is equal to pi. First thing we're going to do is we're going to move over that negative pi to the right-hand side. 1/3 x is equal to pi, and 1/3 x is equal to 2 pi. In order to get rid of the 1/3, we're going to multiply both sides by 3. So x is equal to 3 pi. X is equal to 6 pi. Now, considering how we have 3 pi and 6 pi, we are looking at a subinterval of 3 pi over 4. So we want to have the denominator over 4 being the same. This would give us a 12 pi over 4, and this would give us 24 pi over 4. We're going to go ahead, draw our midline. Remember, our midline is at 5. So in this case, if you want to go ahead and mark this as 4, 5, and 6, our midline would go straight across our 5. When it comes to marking down our x-axis, this would be 12 pi over 4, 13 pi over 4, 14 pi over 4. But notice, as we start coming closer and closer to the right-hand side, we're going to run out of space before we get to that point. One of the easiest ways would be to go ahead and do increments of 3. So if we start off with 12 pi, we can go from 12 pi to 15 pi over 4, 18 pi over 4, 21 pi over 4, and 24 pi over 4. We know that our vertical asymptotes are going to fall on the 12 pi over 4 and 24 pi over 4. We're going to go ahead and find that midpoint on the midline. Now, a cotangent in general would decrease from left to right, and that is for a positive cotangent. A negative cotangent would be the complete reflection of that, which would ultimately be the same as a positive tangent line. Knowing that, we take a look at the a value. As we move to the right, we're going to go up 1. And as we move to the left, we're going to go down 1. We go ahead. Draw our lines and go from there. Let's go ahead and take a look at slide 13. In this case, we go ahead, take a look at our a value, which would be 2. Our period would be pi over b, which is 1/4. This would end up giving you 4 pi as your period. 4 pi over 4 will give you pi as your subinterval. Your midline would be 0, and you would set x over 4 equal to 0, and x over 4 equal to pi. In order to get rid of the denominator of 4, you're going to have to multiply by 4 on both sides. In this case, x is still equal to 0, and x is equal to 4 pi. We're going to go ahead, draw out our midline. In this case, we're still on 0. From left to right. Label out your x-axis, 0, pi, 2 pi, 3 pi, 4 pi. Your vertical asymptotes would be at 0 and at 4 pi. Once you have that all set, find the midpoint of your midline. Keep in mind we were looking at a negative cotangent, which means we are increasing from left to right. Our a value was a 2, so as we move to the right one, we're going to go up 2. As we go left one, we're going to go down by 2. In this case, we would go ahead, draw out this graph as such. Our last slide, slide 14, goes over the different types of equations that we have been working with up to this point. This is an extremely important slide. I would highly suggest that you take a look over it, study it, and kind of understand exactly what occurs at these different points. If you have any questions, please feel free to send me a message at any point.